Alright, first thing first, as you may notice, I'm recording this over the video that I created because of a malfunction that I have related to my instruction video. So today's lesson basically involved chapter 7.5, classifying lines and angles. And right next, we're going to go to chapter 7.6, which is parallel lines and transversal lines. Alright, so right now I'm drawing an example on page 197. There's one line that is tilted with the line segment letter T, followed by P1, followed by P2. As you may notice, P1 and P2 do not have any type of correlation. They are not parallel nor perpendicular. And there's 1, 2, 3, 4, 5, 6, 7, 8. Can you see that 8 and 7 is a little reversed? I'm gonna fix that later. There is an intersection point on the top around 1, 2, and 3, 4. And that is created because of line T and line P1. On the other hand, around 5, 6, 7, 8, there's another intersection point, and that intersection points happen because of T line segment and P2, which is located below. As you may notice, there are some relationship, and we're going to go through some of the example, and by going through, we're going to check one by one for definition. First thing first, the reason that line segment is T is because that line across P1 and P2 is known as transversal line. Now at this point, I'm going to bestow my angle symbol theta. Theta 1, theta 4. As you may notice, I put a little bit of a tick in between because whenever you face angles created by two sets of lines, they're identical. That means angle 2 and 3, you may notice I put two ticks for each of those pair because those two are identical. These relationship, aka whenever you face any type of angle face to face, they are exactly identical. And as you may notice, I'm using my angle notation. These are known as opposite angle. Now let's look at other angle relationship. If you look at angle, which is intersection point, angle 5, 6, 7, 8, 6 and 8, they are opposite angle, so they must share same angle. You can double check with your protractor. 5 and 7, again similar rationale, they are identical. Like I said, I'm gonna change 7 and 8. Those orders are a little wrong. 7 should be on the left, 8 should be on the right, but that part is coming. Now, let's talk about next angle relationship. The next angle relationship is known as corresponding angle. Corresponding angle, they are paired, and then location is quite significant. I want you to put a circle on or square on angle 1 and angle 5. As you notice, and angle 2 and angle 6 with triangle. Now, angle 1 and 5 let's look at those pair first. Angle 1 is located on left upper corner of intersection point that is located above. Angle number 5 is also located upper left corner of second intersection point. This location for angle 2 is upper right, and angle 6 is upper right. So whenever you share the position, so similar position of an angle because of the transversal line, in this case angle 1 and angle 5, and the second pair angle 2 and angle 6, those are known as corresponding angle. In parallel line situation, they basically share the same angle, but in this case P1 and P2 are not parallel lines, so have that in your mind that they are not identical. This is just relationship. Now, next relationship or next angle type is combination of those two. So this type of pair composed of opposite and corresponding style together. So how can we look at those type of pair from an example? Before we getting into that, one thing that you need to know is alternate angle is a name, and alternate angles have two different types, interior and exterior. So let's do interior first. I want you to highlight this angle number 3, which is located in lower left side of the first intersection point. Now, if you look at angle number 6, it doesn't look like they have anything in common, but these two are known as alternate angles, and they are alternate interior angles. The reason it's interior is because angle number 3 and angle number 6, first thing first, if angle number 3 face to the opposite side, that's angle number 2. And angle number 2's corresponding angle is angle number 6. So, if some angle is opposite, and which is angle 2, like I point over there, and if that angle is also corresponding, which is lowercase angle 6, those 3 and 6 is known as alternate angle. Now let's look at another type of alternate angle, but this time, as you may notice, opposite of interior is exterior. Alternate angle exterior basically means the same thing. It's a combination of opposite angle and corresponding angle. Or I like to, the order can be different too. Corresponding then opposite, it really doesn't matter. So if you look at angle number 1 as an example and angle number 7, this is where I'm gonna change it. Like I said, 5, 6, 7, 8. 7 should be on the left, 8 should be on the right. But even if you could look at the previous note, there's no error. It's just 7 and 8 difference. So that angle 1 should be paired with angle 8. Now in any case, let's look at that situation. If I look at angle number 1, which is located on left upper corner of an intersection point, as you may see, it is located between P1 and T. The corresponding angle is angle 5, and opposite of that is angle 8. So it is basically identical as a interior situation. It's a combination of corresponding angle and opposite angle. Technically, if you look at my example, I put angle 2 and 6 and 1 and 8. 1 and 8 actually belong more for interior, and the above example more interior. And I'm going to explain to you why. Because this angle 2 and angle 6 is located inside of the two lines, which is P1 and P2. And when it comes to 1 and 8, these two are outside of the line P1 and P2. So if you actually use your hand and then cover it, can you see that 2, 4, 5, 6 are inside angles? So those are interior angle. 2 and 6 are alternate interior angle because of that reason. On the other hand, if you look at 1, 2, 7, 8, those are outside of the line P1 and P2. So that means angle 1 and angle 8, those are exterior alternative angles. Now let's go to our next mini lesson, chapter 7.6, parallel lines and transversals. As you may notice, the page that you can go with page 200 in workbook, but instead I'm rather going to create a class example using my ruler. I'm gonna have this slanted line 1 and 2. I'm gonna call it P1 and P2, and those are parallel together, and I'm gonna make a transversal line T. Because P1 and P2 are parallel, can you see that I'm creating a arrow line? That's what the notation that we use as mathematicians. And when it comes to transversal, now you have basically theta 1, theta 2, 3, 4. I'm gonna add it, but as you may notice, we can start creating an opposite angle that is identical. So I'm gonna call it like previous example 1, 2, 3, 4, and then 5, 6, 7, 8 below. But one thing that we know is 1 and 4 are identical because they are opposite angles. Similar reason, if I look at 5, 6, 7, 8, we can actually get to the same conclusion. But one thing that I'm going to point it out is my corresponding angle. In parallel situation, corresponding angles share same amount of angle. So theta 1 and theta 5, which is corresponding angle, are identical. This is very significant compared to the previous example, because previous example P1 and P2 were not parallel together. But if those two are parallel together, corresponding angles are identical. That's one of the main conditions. Once that is identical, then here's what happened. Right now, angle 1, opposite side is angle 4, and an angle 4, alternate angle, is angle 3. So basically alternate interior angle, angle 4 and angle 5 are also identical, which we're gonna see each other soon. Now, if I look at corresponding angle of theta 4, we're gonna end up having theta 8. Now, do you remember corresponding angles are identical? So that means theta 1 will eventually equal to angle 8. And how that happened, there are several reasons. Number one is theta 1's opposite angle, theta 4's corresponding angle, theta 8, they're identical. Or you can say theta 1 and theta 8 is alternate exterior angle. They are opposite and corresponding. That's my rationale. And you can call it simply alternating angles. So long story short, that will create a certain pattern. That will create a certain pattern in the world of parallel lines. Because as you may notice, 1 and 4, then followed by 5 and 8, we can list them all together that they are identical. So 1 is equal to 4, then 4 is equal to 5, which is also equal to 8. In parallel line situation, that is possible. If you look at other thing, which is 2 and 3, they're opposite together, and corresponding pair of that 6, followed by its opposite 7. Those relationships are established just because P1 and P2 are parallel together. That is today's lesson. And as conclusion, more than one pair of identical angles can be figured out. Your homework for today is page 198 to 199. Do just odd numbers. And when it comes to the next chapter, 7.6, you can do everything on page 202. That is what you can do.